Today we are going to discuss lipid analysis in food. So this is one of the important analysis in the food industries and also in many quality control laboratories in the food sectors. So lipid analysis. So we know the lipids will constitute the two things, that is the oils and fats. Okay. So collectively it is called as the lipids. So lipids are a group of substances which are soluble in ether, chloroform and other organic solvents, and which is sparingly soluble in water. Okay, so this means lipids will be soluble only in the organic solvents and sparingly soluble only in the aqueous, that is the water. So lipids mostly constitute by the TAG. TAG means triacyl glycerol molecules, which is mostly hydrophobic in nature. And some acyl glycerols like di and monoacyl glycerols are both having they're having the both properties, that is hydrophobic also and hydrophilic also. So hydrophobic means it will be attracting by the water, it will not attract by the water molecules, and hydrophilic means it will be mostly soluble in the water. Okay, so we can call it as a water loving and water hating molecules. Okay, so the next is SCF, that is SCF means a short chain fatty acids, that is mostly the carbon count, that is like C1, C2, C3, C4. Okay, so the molecules which is having the carbon count from 4 carbon atoms means, so that will be called as short chain fatty acids, and which is completely miscible with water and insoluble in solvents. Okay, so this means these kind of the fatty acids will be soluble in the water and not in the solvents. Okay, so this is the difference between the TAGs and diacylglycerol and monoacylglycerides and short chain fatty acids. Okay, the next we will see the general classification of the lipids. Okay, so lipids are classified into three types. Okay, the three classification, that is first classification is simple lipids. Okay, simple lipids means it's an ester of fatty acids with alcohol. The perfect example for the simple lipids is fats and waxes. So next is the compound lipids, which contains a group addition to ester of fatty acids with an alcohol. Example for compound lipids means, that is a phospholipids, erythrosides and sphingolipids. So derived lipids means the substances derived from neutral lipids or the compound lipids. Okay, so that is called as derived lipids. Okay, simple lipids means is a simple example, that is a ester of fatty acids with alcohol. Compound lipids means it contains a group of additional compound, that is a phosphorus, that's phospholipids and cerebrosides and sphingolipids. Then finally derived lipids means which are derived from compound lipids or neutral lipids, that is called as a derived lipids. Examples for the derived lipids is sterols, fat soluble vitamins, hydrocarbons and long chain alcohols. So this is the structure for ester. Okay, so that is like a simple lipids. Okay, so how this ester is formed? So that is a reaction between acid and alcohol. Okay, so how the ester molecule is formed? Okay, so it's a reaction between the carboxylic acid plus an alcohol. So when it liberates the water molecule, the ester is formed, as we can see in this reaction. And the compound lipids. Okay, the compound lipids, you can see, that is the example I have given is the phospholipids. So this is a diacylglycerol molecule and this is the phosphate group. So when this phosphate molecule is linked with this diacylglycerol, the one water molecule will be liberated. So this is the combination of phospholipids. Okay, so this is how the phospholipid is an example for simple lipids, and the second one is an example for the compound lipids. Okay, next we can see the content of lipids in foods. So the foods contain the many types of lipids. Example DAGs, that is the triacylglycerol molecules, and the phospholipids. So there will be another some two classification again, that is a liquid TAGs at room temperature. Okay, so that is mostly as an oils. Okay, we can give oils an example for the liquid triacylglycerol molecule. and the solid triglyceride molecules at room temperature, that is called as fats. So this is how this is why and why lipids having a both terms, that is the oils and fats. Okay, the example for fats is a lard and tallow, that is from mostly from animal origins. And this is shown some percentage of fatty acids on a wet weight basis for the different food products under legumes and meat, poultry and fish and nuts and egg, fruits and vegetables, cereals, bread and pasta, dairy products and fats and oils. So importance of fat analysis in food. So it is an accurate and precise quantitative and qualitative analysis of lipids in food materials. Okay, this is important for accurate nutritional labeling. We can see many different products and the background information they are giving as a nutritional information. So definitely the analysis of fat is important. Then only we can know that we can give that information in the packaging. So to determine whether the food meets standards of identity or not. So we all know the what is the standards of identity. For example, mayonnaise, we all know that. So mayonnaise means there should be some percentage of fatty acids, definitely it should be there. Then only it will be claimed as, you can claim as a mayonnaise. Okay. So instead of the reduced percentage of fat means, and you cannot claim that product as a mayonnaise. So that is the thing called as standards of identity. Definitely we have to analyze the fats, then only we know what is the percentage of fatty acids given in the product. So next, to ensure the product meets manufacturing specifications. Okay, so for example, manufacturing specifications means, so for example, I can give that is an ice cream. Okay, the difference between the ice cream and the frozen dessert. We all know that ice cream, what is ice cream means, that is a from dairy. Okay, so frozen dessert means instead of dairy, the milk fat, they will people will be using a oils. Okay, so that is called as a manufacturing specifications. So definitely that also we can know by analysis. So inaccuracies in analysis and also prove costly for the manufacturers. Okay, so whenever we doing the inaccurate analysis, definitely it is a cost, that is a loss for the manufacturers. Okay, so for example, the results of the products of undesirable quality and functionality. Okay, so if we give improper results to the manufacturers, definitely based on that only they can improve or they can decrease the levels of some unexpected compounds which is in the present in the oils. So next is general consideration. So lipids soluble in organic solvents or sometimes insoluble in water. So water insolubility is taken as an important analytical property to measure the lipids. So separation of lipids from proteins and water and carbohydrates in foods is very important for the lipid analysis, because when we are analyzing the lipids, we are going to analyze only the lipids. So in the presence of proteins or other compounds, that is unnecessary for the analysis. So next is glycolipids, that is soluble in alcohols and low soluble in hexane. Okay, that means soluble only in the solvents, but it is low soluble in, that is hexane, that is a polar and non-polar variants. So next is a TEG, which is soluble in hexane and petroleum ether, and it is not soluble in the polar solvents. So wide range of hydrophobicity of different lipid makes a selection of single universal solvent which is impossible for lipid extraction on foods. Okay, I cannot say hexane is only the solvent we can use for lipid analysis. So because of this hydrophobicity, varying hydrophobicity, we have to use based on the hydrophobicity of the fat or lipids, we have to use the polar solvent or non-polar solvent for the fat extraction. So some lipids in foods are complex with lipoproteins and lipopolysaccharides. Means the lipids are associated with the protein molecules, and lipids sometimes are associated with the polysaccharides. Okay, so successful extraction requires that bonds between lipids and proteins that should be broken down for the perfect lipid analysis, so that lipids can be freed and solubilized in extracting organic solvents. So next, the classification of fat extraction methods. So there are three different classifications. So one is solvent extraction methods, non-solvent extraction methods, and instrumental methods. Solvent extraction methods is again classified into four, that is continuous solvent extraction method, example goldfish method; semi-continuous solvent extraction method, example oxalate extraction method; then discontinuous solvent extraction method, the example is Mojonia method; then finally the total fat extraction method, that is GCMS. So the second one is non-solvent wet extraction methods. The two types, that is a Babcock method and the Gerber method. Then instrumental methods, there are many instruments, analytical instruments we can apply for the analysis. So that is infrared method, X-ray absorption method, nuclear method, and the accelerated solvent